G'day YouTube, Warbles on a lot here. Mad scientist time. Welcome to the theory of Elbarsoles. What do you mean you've never heard of an Elbarsole? Surely. Looky here. This is an elbow seen from behind. This is an elbow seen from the front. This is an elbow seen in X-ray. And here we see the elbow drawn from the side. Anybody who's ever designed and built anything can clearly see that an elbow is a brilliant piece of design and engineering. Particularly because it's a piece of biological engineering. It has to grow itself in place. It has to repair itself. It has to maintain itself. Its task is fairly specific. It has to allow one's arm to bend in the middle, and it has to permit the hands to be rotated through the long axis of the arm, or of the forearm, to the tune of about 180 degrees. That's what an elbow's got to do. That's its job. Its job dictates its form, because form follows function. Now, consider an arsehole. This here, this is an arsehole. Completely different. It has a different job, a different function, therefore its form follows the function, and it's a completely different piece of engineering. Can you imagine what would happen if somebody was to attempt to combine an elbow with an arsehole? If you could build an elbow that could see things, or an eyeball that could function in the middle of your arm, between your wrist and your shoulder, it would be a really, really difficult piece of engineering. It might be able to do one job pretty well and the other job kinda, or vice versa, but it'll probably never be as good an eyeball as an eyeball. It'll probably never be as good an arsehole as an arsehole, and it'll probably never be as good an elbow as an elbow. However, some people like to think that they can mix and match, combine an elbow with an arsehole. If they're really, really keen, they'll try to make an Elbarseyeball. They'll try to get their Elbarsole to work like an eyeball, if you see what I mean. Perhaps I'm not making myself clear. Let us consider that this is a boat. It is a sailing boat. As such, it's already a very clever piece of design because it's an interface vehicle. It floats on the interface between the water and the atmosphere, and it captures energy flows between the ocean or the water and the air, and it uses balances of those forces in order to navigate, to move. It's a very clever bit of work, but it won't fly. It won't fly at all. And meanwhile, this is an aeroplane. It won't float, and it certainly won't sail when it's not floating, but it flies really well. It's a bit like the difference between an elbow and an arsehole and an eyeball. Now, if you were perhaps sufficiently deranged as to inflict onto yourself all the miseries of attempting to combine a sailing boat with an aeroplane, you'll get something like this. And this, unless I miss my guess, this is an Arselbow. Whereas, when you go putting your existing aeroplane onto a pair of little boats called floats mounted underneath, you don't get an Arselbow then. What you get is an Elbarsole. Now, some of you may be wondering, why is it such a horribly bad idea to try and combine an aeroplane with a sailing boat? I mean, surely you can then use all of the water surfaces on the earth as your runway that you haven't got to build, and it'll be fun. Well, there's a funny thing about boats. They work by floating. They displace more water than the boat itself masses, therefore they sit on top of the water. But some of them sticks down into the water, and if you're going to turn your boat, rowboat, as in this case, into a sailing boat, like these, then there is a specific arrangement regarding how much sail area you have on top of the bit that does the floatiness in comparison to how much sticks down into the water, how far it sticks down, and whereabouts between the front end and the back end it sticks down. Broadly speaking, if we're talking about a single-hulled, multi-masted ship, it won't have any extra special keel, retractable or fixed, sticking down underneath it, because there's enough of it poking down into the water that if the wind blows on the sails and tries to push the boat sideways, there's enough side area under the water that it's easier for the boat to go forward or backward, and the hull is shaped, cunningly artificed, in such a way that it's easier for the boat to go forward rather than backward. Then you can change the angle of the dangle of your sails to the prevailing wind, and if you go fast enough, you've got to change that again to the angle of the apparent wind. You can balance your little rudder wig-wagging away at the back end of the boat, and yes, you can actually manage to sail upwind. We're talking a little sailing dinghy, and down about here, behind the mast, they'll have a centreboard, which they can stick down when they want to use it. Point is, sailing boat design is very kind of fixed in terms of what works. And the problem with your Herigo plane, as a sailing boat, is that it's designed to fly through the air. So it's got most of its surface area, side area, well behind the centre of pressure on the wing, and the centre of gravity is going to be underneath your centre of pressure within limits. And then it's going to have a hull that's designed to break away from the water at high speed so you can get off the water. If you leave that thing with its engine switched off on the water, it is going to be blown downwind. It cannot sail. It's the wrong shape to sail. You've also got the problem that if you use it near the ocean, the tide comes in and out every day. So the water's going to be moving backwards and forwards past the buoy connected to a big heavy lump of concrete on the bottom of the water. And you're going to be tied up to that buoy, and as the water goes backwards and forwards, the bottom of the boat, the hull, is going to want to stream downwards from its attachment point up here at the nose. Meanwhile, the aeroplane itself, the body of the aeroplane, it is designed so that if it's held by the nose, it wants to swing downwind. If you get a significant argument between the direction of the wind and the direction of the current, the aeroplane is quite capable of digging its float in, turning upside down, and investigating the submarine performance of your Elbarsole. If, on the other hand, we've got a much smaller kind of a flying device, boat, hybrid, people may be tempted to wait till the tide's high and pull it up onto the beach and let the tide drain away around it, ebb away, I think is the correct word. And then you'll have the thing anchored by its own weight safely on the wind, doesn't matter, safely on the beach, doesn't matter what the wind does, it'll be fine. But of course you can't use it until next time the tide rises up that high. If you're operating one of these things on your own in a remote country, you might spend your whole day doing nothing but move the seaplane backwards and forwards, up and down, as the tide rises and forwards on the edge of the estuary that you're trying to use as a runway. Meanwhile, when it comes to flight performance, you've got all the extra weight and all the extra drag of these float thingies underneath you. So for the same engine, the same wings, the same fuselage, a seaplane is always going to be heavier. It's always going to burn more fuel to cruise at the same speed. It's always going to have a longer takeoff run. It's going to be more expensive to operate. And if you're using salt water, it's going to corrode at a ferocious rate, because most metal aeroplanes are built out of aluminium alloy, which doesn't like salt water. You see why I'm thinking that an aeroplane that can swim is an Elbarsole. It's not a good elbow. It's not a good arsehole. It'll kind of work a bit on a good day as either one, but it's never as good as an actual arsehole. It's never as good as an actual elbow. A seaplane or a flying boat is not as efficient, fuel efficient, aerodynamically efficient, no matter how you want to cut the mustard. It's not as efficient as an actual boat. It's not as efficient as an actual aeroplane. Yes, they've built amphibious floats, and now you can carry wheels around all of the time and burn all the fuel to lift them off into the sky every time you operate your seaplane. And or you can pay to buy the fuel and burn it to drag the floats through the air all the time when you're operating it as a land plane. Some very remote or very obscure applications it makes sense. For example, firebombing. If you put floats underneath your crop duster, then you can scoop up water on the fly, so to speak. Just drop a scoop into the water and fly over the top of the dam, lake, river, estuary, wherever it is. If you don't put floats on, then you're going to find yourself turning upside down. That happened to a fella called Cole Pay. So yeah, that's your standard Elbarsole and Arselbow. But what about the concept of the Elbarseyeball? Well, for that, you just magnify the level of difficulty by adding another thing that's really tricky to do. Like, I've heard of people who lived in a very rugged mountainous part of the country, flooded glacier geography it was called. So they've got lots and lots of water and steep hills covered in forest. They wanted to play with a sailplane, so they built a sailplane seaplane and used to tow it behind speedboats. Never ever got it off the ground. Other people put gyrocopters on floats. They're working towards their Elbarseyeballs status, but the serious Elbarseyeballists, here's what they do. They take the concept of the flying boat and they give the thing jet engines. Yeah. The Saunders Roe Company did this in the 1950s. The theory was that Britain was going to police the colonial empire with jet fighter flying boats. It was subsonic. They only ever built 2 of them, and maybe it was only 1. But anyway, it crashed very, very badly when a lump of wood floating on the water came up here, hit the hull, was carried out by the splash, knocked the float off. And the impact of the wood stoving in the hull and knocking the float off turned it sideways, and then it cartwheeled and it went upside down. The pilot was very lucky to survive. But yeah, that is your genuine British Elbarseyeball. An aeroplane crossed with a boat with 2 jet engines stuck up it. Of course, the Americans couldn't possibly be outdone. The US Navy put its twin-engined supersonic jet fighter on water skis. About 3,500 pound of thrust each engine, 5,000 pounds of thrust with afterburner. They tried getting it to work with 2 skis. They tried getting it to work with 1 big single V ski. Charles E. Richburg, a former US Navy pilot, lost his life in the Sea Dart crash. After taking off, he started the show with a high-speed pass, lighting the afterburners for added impact. It was this manoeuvre which led to the catastrophe that ended Richburg's life and seriously harmed the F-2Y program. A significant pitch down effect from use of afterburner had been noted in high Mach model tests, and even during a test flight a few days before the demonstration. As Richburg lit the burners during his flyby, the Sea Dart pitched down, and he corrected with the stick. This set up an oscillation, the nose pitching down again, this time violently enough to rip the wings off. The Sea Dart broke up. The rear fuselage, engines still in place, transformed into a fireball slashing across the sky. The forward fuselage and cockpit, intact but inverted, 1 hydro ski still attached, tumbled towards the waters of the bay. Rescue boats hurtled in the direction of the wreckage, and the divers reached the site quickly, but Richburg died shortly after impact. Unsurprisingly, after investigation, the cause of the divergent pitch oscillation that had caused the airframe failure was judged to be a combination of factors. Richburg, while a highly skilled seaplane pilot, had relatively little experience in high-performance jets and corrected the initial pitch down too vigorously. This was exacerbated by the early, relatively crude, fully powered controls. They incorporated a détente at neutral pitch that needed to be overcome, increasing the stick force required to counter a sudden pitch down. Not for nothing was a pilot-induced oscillation in fast jets of the time known as the JC, for Jesus Christ, manoeuvre. The low altitude necessary for the demonstration increased the dynamic pressure that the airframe was subject to, leading to the structural failure just after the oscillation. And there we see Richburg's Fireball, with Richburg still strapped into the cockpit in that particular shot. And there's the rest of the fuselage and engines. And of course, this fool's errand, folly, was funded by the taxes contributed by the city's ends of all Uncle Spam. Compared to the Elbarseyeball produced by the French, one would have to say that the Convair Sea Dart actually almost made sense. And of course, the other factor here is that every now and then somebody manages to build themselves an Elbarseyeball which actually makes sense to the point where it goes into production and it makes it into service. A jet fighter that, with half fuel and no payload, can take off like a helicopter and land like a helicopter. That's why they call them stovels. Short takeoff, vertical landing. So there you go. And now you know, therein at B, the Warbles on a lot theory of aeronautical Elbarseyeballs, which holds that just because something can be done, in theory, does not mean at all whatsoever by any means that it should be attempted, unless you've got money to burn, and or if you're selling death machines to the military, because then nobody will care what it costs you to do it. Look at that, a genuine Elbarseyeballs. That one's got a rocket assist. They thought this was going to get them a supersonic fighter that was independent of aircraft carriers. Almost anything's possible if you throw enough money at it. Funny that. And that's the bloke with his pilot-induced oscillation. And they kept playing around, like that didn't stop them. There's now 4 of these things in museums. The ultimate Elbarseyeball. A supersonic jet fighter on water skis. If I hadn't pirated this bit of video from Atomic Cafe's video on the topic, most of my subscribers would probably think I was bullshitting. But there it is. The aeronautical theory of Elbarsoles, Arselbows, and Elbarseyeballs. Warbles on a lot to YouTube. Ciao.